And for our opener, we're just reviewing part of what you all quizzed on right before we went on break, and that's the distributive property. The only thing that was kind of new from what we did was distributing the 2x. We've distributed a number before, but when we distribute the 2x, we need to add the exponents. When I do 2x times 5x, 2 times 5 gives me 10, x times x. I add those exponents to make it x squared. 2x times 1 is just simply 2x. Now remember, we cannot combine those terms after multiplying here because they are not the same term. They have different exponents. Their variable is the same, but the exponents are different. So we cannot combine them, or at least not in this case. That is as simplified as we can write this expression. Then the negative 4. When I distribute that, I'm just multiplying the coefficients or the numbers. Negative 4 times 5 is negative 20. So it's negative 20x. Negative 4 times 1 is just negative 4. Once again, we cannot combine those terms because they don't have the same variable in this case or the same exponent. Nothing is the same about it. All right, so we're going to continue to multiply today, but we're going to multiply a little bit more.
This concludes our...
So before we get into the actual problems, let's just review a couple things about multiplication, how we might see it, and how this can work with just simply numbers. Okay, so first, remember that if we have numbers written next to each other, specifically with parentheses here, this is multiplication. 6 times 10, that is 60. Okay, so when we see the parentheses next to each other, that is implying that there is multiplication there. Okay, so if we don't recognize that as being multiplication, pick up a pencil and start writing. Okay, that's a problem. We're going to have trouble doing that. Now, down here, when I have a number distributing to other numbers in the parentheses, there's two ways that we can do this. Okay, a lot of us, since we just worked on the distributive property, we might say, oh, I can do 6 times 7 and call that 42, and then 6 times 3 and call that 18, and 42 plus 18, well, I can add those. That's 60. Now, that's not the only way that we can multiply these terms or to simplify this out. We can just follow order of operations, right? I can add what's inside the parentheses first. So in this other one, I could do 5 plus 5. That's 10. So this is really 6 times 10 to get us to 60. Okay, same thing with the last one. I can do the parentheses first. 12 minus 2 is 10. 6 times 10 is 60. So when it's just numbers, we have a couple ways of how we can go about doing this. Again, when I see this, I probably would have simplified inside the parentheses and then done the multiplication, okay, rather than multiplying twice and adding those after. What we're going to work on today is where we have 2 terms times another 2 terms. Now, if we were to do this using the distributive property, we would do 2 times 7 and 2 times 3. So 2 times 7 plus 2 times 3. Then I would do 4 times 7, so plus 4 times 7, plus 4 times 3. Okay, so the number in the first set of parentheses multiplies to both in the second set. The second number in the first parentheses multiplies to both as well. That'd be 14 plus 6 plus 28 plus 12. What would that be? 20, 48, 50, 60. And that seems like a very long way of doing that. Okay, when it's just numbers, I don't know that there's any person in here or anybody that's engaging in math that would say, oh yeah, I'm going to distribute all of this. Okay, again, most likely what we would do is we would say, oh, well, inside the parentheses, I can simplify. 2 plus 4 is 6. 7 plus 3 is 10. Then 6 times 10 gets us to 60. Much easier than doing that whole kind of distributive property that we're going to investigate today. All right, but this is how we're going to have to multiply them out because we're not able to simplify the terms inside the parentheses. And we're going to be working with multiple terms with the problems we're covering today. So let's look at what we're actually trying to do. Okay, let's transfer that same idea to multiplying polynomials. One thing I want to point out is that this is considered a binomial. They're both considered binomials, meaning there are two terms. That prefix bi is implying that there's two. Nomial is number of terms that we have. Okay, so when we have two terms times another two terms, there's a lot of ways of how this gets explained. Some of you that have done this before have heard the word FOIL, where you do the first, so 2x times 5x. You do the outers, so 2x times 1. You do the inners, negative 4 times 5x. And then the last being negative 4 times 1. That's for those of you that know FOIL. I don't like using that acronym FOIL because it doesn't always work. It only works for a binomial times a binomial. I instead focus on what is the concept for how we do this multiplication. Well, really what needs to happen is this 2x needs to multiply to both things in the parentheses. So 2x times 5x is 10x squared. 2x times 1 is 2x. So this 2x multiplies to everything in that second set of parentheses. Same thing with this negative 4. Negative 4 times 5x is negative 20x. Negative 4 times 1 is negative 4. Okay, so that is the same result I would get if I followed that FOIL acronym. And again, it doesn't really matter to me how we end up multiplying this out. One thing we should always do after multiplying is see if there are any like terms that we can combine. So 2x minus 20x is negative 18x, and then minus 4. The other thing that we could use here to multiply these terms out are those boxes. We use the boxes on some of the problems we had that we covered before we went on break. And I had said that a lot of the work with the boxes is gearing us up towards ultimately factoring, where we're going to use the boxes with everything we use to factor. Well, factoring and multiplying or distributive property are basically the undoing of one another. So I'm going to really push us to use these boxes, okay, just like what we were kind of doing before break. But now there's more that we're multiplying. So when I'm multiplying using the boxes here, we know that this 2x needs to multiply to the 5x and the 1. And so the way that we represent that is we'll take this first binomial expression, so the 2x minus 4, and I'll either put that down the side or along the top. So I'm going to put this down the side. So this 2x, it then needs to multiply to the 5x and to the positive 1. And that's what these boxes are going to represent. Okay, the result of us multiplying 2x times 5x and times 1. We will also need to do the same thing with the negative 4. It also needs to multiply to 5x and the 1. So I'm going to put that negative 4 down the side as well. So really we'll take each term here, either put it down the side or along the top, and know that if you were to switch these, it doesn't matter at all. It's the exact same. And now we just do the multiplication. That's why the boxes are so nice, because it helps us keep track of everything that needs to multiply. 2x times 5x is 10x squared. 2x times 1 is 2x. 5x times negative 4 is negative 20x. Negative 4 times 1 is negative 4. So the insides are the result of our multiplication. The only thing left that we need to do is combine like terms. The 2x and the negative 20x, they combine to give me negative 18x. So this is 10x squared minus 18x minus 4. So I combine those together. And that is all that we're doing in this lesson. After you have this down, go and flip the page over. All right, let's just start here. Why don't you all fill out these next two? They're basically already ready to go. Let's wait and do 3 and 4 together. But why don't you all do 1 and 2 right now? Okay, I'll give you like 3 minutes. Should be pretty quick. Again, the boxes make sure that everything that needs to get multiplied does get multiplied. So as we work through this, I'm going to encourage us to use these boxes, even if you feel like you've done this before, even if you feel like it's easy without it. Okay, so x times x, x squared. 3 times x, 3x. X times negative 2, negative 2x. 3 times negative 2 is negative 6. I then am looking for any like terms. 3x minus 2x is a positive 1x. So this entire expression simplifies to x squared plus x minus 6. Number 2, not any different in terms of the setup. 2x times 3x is 6x squared. Negative 3 times 3x is negative 9x. 2x times 5 is 10x. And then negative 3 times 5 is negative 15. Once again, I have these like terms. 10x minus 9x, that is 1x. Okay, so when you get to the actual problems, again, there's not going to be boxes drawn for you. You're going to have to draw those boxes. And don't be lazy, actually draw them. It doesn't take that much time, and it really helps keep everything organized. And again, ensures that everything needs to get multiplied is actually getting multiplied. So these next two, we get a couple different things that are happening here. First off, the squaring. Always when we see these exponents, we should start with what does it mean to square that term? It means to multiply it by itself. This is not an exponent property where I can take the 6 and call this 6 squared and the 4x and call it 4x squared. Right? To square something, it means to multiply it by itself. So when I see 4x plus 6 squared, that really means 4x plus 6 times another 4x plus 6. And so I have a binomial times another binomial. And to do that, I'm going to use a box. So I'll draw my box. Put 4x plus 6 along the top. 4x plus 6 along the bottom. And now I can start to multiply. 4x times 4x is 16x squared. 6 times 4x is 24x. We get another 24x. 6 times 6 is 36. And last thing we need to do is combine like terms with the 24x's. So that's 16x squared plus 48x plus 36. Don't skip ahead. Yeah, Ford, question. Shh. Yeah, okay. So that's, again, a really common thing that students will do. They'll see this 4x plus 6 squared, and they remember that when I have an exponent raised to an exponent, we can multiply those. So a lot of students will see this, and they'll go, oh, this is 4x squared plus 6 squared. And some of them might even say that's 16x squared plus 36. But what's missing is this 48x. So if you're just squaring those terms, you're missing the entire 48x that we get when we actually square those terms together. So this is not that exponent property that you're thinking of, where if I have like 2xy to the power of 2, then yes, I will multiply all those exponents. Okay, but that's only applicable if everything in the parentheses is being multiplied or divided. If we have something that's being added or subtracted, we can't apply this exponent property. Okay, so it's very different. Again, when you're confused about it, just think about what it means to square something. And a lot of you would say it means to multiply it by itself. That's why I write that out of the 4x plus 6 times 4x plus 6. So this is the simplified expression here. Okay, let's do number 4. And then I'm going to have you all do, you know what, let's not even do that. Let's have you all do 5 and 6 real quick. Everyone do 5 and 6. We'll start with that. All right, for everyone watching online, you can check your work here with 5 and 6. In terms of the setup, nothing changes. You'll just take one of the terms, put it along the top, the other term along the side. And remember, it doesn't matter if you switch these. In this case, we do get a negative 12x squared and a positive 12x squared that cancel out. So your final simplified expression is 16x to the 4th minus 9. With 6, we do have that second variable, so it does make it a little more complicated. So when I have like 2x cubed y squared times 5xy cubed, the numbers get multiplied. 2 times 5 is 10. The same bases, I can add those exponents. So x cubed and x is x to the 4th. Y cubed and y squared is y to the 5th. And I do that with all 4 expression or all 4 multiplication problems. And I don't get any like terms. They're all different because they all have different exponents. Yes, they all have x's and y's, but this is one entire term that cannot be added with others. So we just got to write these all out as one long expression here. All right, now go ahead and work through 7 and 8, and that's the end of this lesson here. Second. So 7, again, nothing really to kind of mention here. Nothing odd that happens. You should end with 12x squared minus 36x. I'll bring it to you. Okay, so 7, 12x squared minus 36, minus 36x plus 15. And then with 8, again, be careful of that squaring. Anytime we see exponents, always start with, okay, what is this telling us? It's telling us to multiply it by itself in this case. So 3 minus 2x times another 3 minus 2x. Again, the negative 6x's combine together to give us negative 12x. And then your final expression being 4x squared minus 12x plus 9.